Welcome back. So in our last set of videos, we went ahead and explained and defined inclined planes, which in my opinion is the simplest of all the simple machines. Today we're going to be talking about the lever, which is almost simple, but it's really the most well-known of all of the simple machine. And in fact, the term leverage is pretty much synonymous with the term mechanical advantage. So let's go ahead and define a lever. And all it is a rigid bar with two opposing forces turning about a fulcrum. Turning about a fulcrum. As long as we're defining, let's go ahead and define what a fulcrum is. A fulcrum is pretty simple. It's simply a sensor point of a rotating lever. Rotating or a turning lever. And then a fulcrum is denoted by a symbol of a triangle. And so we can draw a quick example. It sort of looks like a seesaw if you look at it. And this is just a fulcrum. And the fulcrum doesn't have to be in the middle. And we'll talk about that in a little bit, or in just a couple seconds. But we got two opposing forces acting in opposite directions. So one's wanting to go one way while the other is wanting to push this the other way in this sort of circular motion. And as you can see, the fulcrum is right in the center of our rotating lever. And we have three types, and they name them in these really, really complex ways. They're really creative with their names. We got the first class lever. We, of course, have the second class lever. And the third one is, of course, Alpha Centauri lever. I'm just kidding. It is simply the third class lever. And even though the three different types of levers, they all basically follow the rules of a regular lever, which is a rigid bar. So let's go ahead and draw that part. All three of them have a rigid bar. All three of them have opposing forces trying to battle it out. So we got a downward force here, a weight we're trying to lift up, with an opposing force here fighting it. And then here we've got a force pulling up, fighting a force being pushed down. And all three of them are turning about a center point or a fulcrum. And so they're all basically levers. The only difference is the location of where you put the 3 points of contact, the force resistance and the force effort, which are the two opposing forces, and of course the fulcrum. And so let's talk about each one in turn. Let's of course start with the first one, the first class lever. So the first rule of the first class lever is the fulcrum is in the middle. So the fulcrum is in the middle. And then FR and FE are on either side. So over here we have FE on the right. We can put it on the left though. It doesn't really matter as long as FR and FE are on either side. So we'll call this one FE and this one FR. And both are an example of a first class lever because they follow the second rule, and that is FE and FR are on either side. Now, as for a second class lever, you can see it's a little different. So we still have the rigid bar, but the difference is we have the fulcrum on the outside, not in the center. You might say, well, what happened to it rotating about the center? Well, it is kind of rotating around the fulcrum still. So it's still rotating the same. They're still rotating about the fulcrum, but the fulcrum is somehow on the outside. And so in this one, we have the fulcrum on the left. I just wanted to show you that could be on either side. And we have FE always on the outside in the second class lever, and the force resistance always in the middle. And so these are our rules. The first one is in the second class lever, FR is in the middle. Middle. And the FE and the fulcrum are on the outside. On outside. versus a third class lever, which if you look, we'll go ahead and draw the fulcrum still on the outside. And if you notice, it looks very, very similar to a second class lever. In fact, you might not see the difference at first, but if you notice what the difference is FE is in the middle. So at first glance, it looks like a third class lever looks like a second class lever, but it's actually kind of the exact opposite. Now FE is in the middle, which means, by definition, FR and the fulcrum are on the outside. And so now that we've defined the different types of levers, hopefully in the next couple of videos we can start figuring out how to calculate the mechanical advantage of each type of lever.